Hello there, and welcome to the Sleepy Science Secrets. Tonight, we are going to explore one of the most quietly astonishing questions you could ever rest your mind upon. What if the sun, that warm, generous, ancient light that has watched over every single morning of your life, simply wasn't there anymore? Not with a bang, not with drama, just gone. A soft absence, like a candle gently blown out at the end of a long good evening. Now, here is the beautiful thing. Science has actually thought deeply about this, and what it found is not frightening at all. It is full of wonder. It is full of stillness. It is a story about how Earth would carry on, how the ocean holds warmth, how life finds its way even in the deep and quiet dark, and how the universe, vast and patient, barely notices a star missing. So, settle in, pull your blanket a little closer, let your shoulders drop, let your breathing slow, and let's drift together into the soft, curious world of what would happen if our sun simply stepped away. There is something almost tender about the way the sun says goodnight each evening. It doesn't vanish, it just slides slowly beneath the horizon, leaving behind colors you cannot quite name, purples that belong only to that moment, oranges that exist nowhere else in the world. You have watched this many times. You have felt that particular kind of peace that comes with the fading of light. Tonight, imagine that feeling stretched out, not for one night, but for a long, slow journey into a new kind of world. The first thing scientists tell us is something that might surprise you. If the sun vanished this very moment, you would not know. Not right away. Not for a full 8 minutes and 20 seconds to be precise. Light travels at an almost unimaginable speed, about 300,000 kilometers every single second. And even moving that fast, it takes sunlight nearly 8.5 minutes to cross the distance between the sun and the earth. So, for those first 8 minutes, everything would look completely normal. The sky would still be blue. The light on the leaves outside your window would still be golden and warm. You would have no idea that anything had changed at all. There is something almost meditative about that thought. 8 minutes of ordinary, beautiful light still arriving, still landing on your skin, still making the world look exactly as it always has, even though the source of all that light no longer exists. It is like receiving a letter from someone far away, written weeks ago with great warmth and care, arriving in your hands full of love, even after everything has changed. The light you are seeing is always the past. Every photon that has ever touched your face is a small message from 8 minutes ago. The sun, in a way, is always speaking to you from slightly before now. Gravity, however, is a different matter entirely. If you enjoy thinking about strange and beautiful things, here is one for you. Gravity, like light, also travels at the speed of light. So, in that same 8 minutes and 20 seconds, Earth would continue in its orbit, just as it always has, curving gently around a point in space where the sun used to be. The gravitational pull would still be there, still guiding us, still holding the planets in their familiar paths for exactly 8 minutes and 20 seconds. And then, all at once, both the light and the gravity would simply release, not violently, not dramatically, just a quiet letting go, the way you release a breath you have been holding for a long time. If you feel comfortable, Let your eyes close for just a moment, right now. Think about that. 8 minutes of a world still held together, still lit up, still beautiful, coasting on the memory of a star. There is something so human about that. We do that too, don't we? We keep going on the warmth of something good long after the moment itself has passed. Memory is its own kind of light, and it travels in its way just as far. After those 8 minutes passed, the sky would begin to darken, but not all at once and not completely. This is where things become very interesting and also surprisingly peaceful to think about. The day side of Earth, the half currently facing the sun, would go dark first, and the night side, the side you are perhaps on right now as you listen to this, the side that was already holding the dark close, like a familiar old friend, it would barely change at all. A night is still a night, even in a world without a sun. Stars, of course, would become remarkable. Within minutes, the sky would fill with stars in a way that most people alive today have never seen. Light pollution, all those gentle orange glows from cities and towns, would gradually fade as power systems adapted over days and weeks. But even in those very first hours, the stars would begin to appear in numbers that would take your breath away. The Milky Way, which most people on Earth cannot currently see because of artificial light, would arch across the sky in a river of silver and soft white. Hundreds of billions of stars, each one its own sun, each one surrounded perhaps by its own quiet planets. Here is a fact that is easy to forget in daily life. There are more stars in the observable universe than there are grains of sand on every beach and every desert on Earth. Every single one of them is burning, warm, alive with light. The universe is not dark, it is overflowing with light. We just happen to live near one particular star that gives us such a bright local sky that we cannot see most of the others. Losing that one bright star would, in a strange way, give us the gift of seeing the rest of the family. And if you feel moved to leave a little comment below, letting us know what you find most fascinating so far, the idea of 8 minutes of lingering light, or the sudden gift of the stars, that would be a wonderful thing. The sleepy science community is such a warm and curious group of people, and every comment is such a kind little hello in the night. In those first days, the temperature would begin to drop, not catastrophically, not in a way that would be immediately alarming, but gently, steadily, like the slow cool of an autumn that never quite arrives at spring. The surface of the Earth would cool, and scientists have calculated that within a week, the average surface temperature of our planet would fall from about 15 degrees Celsius, the comfortable room temperature of a good day, to around -18. That is cold. That is the kind of cold that makes you want to burrow deeper into your blankets, the way you might right now. But here is something the cold cannot touch: the oceans. The oceans of Earth hold an extraordinary amount of heat, far more than the land, far more than the air. Water has a property called high specific heat capacity, which is simply a beautiful way of saying that water holds warmth for a long, long time. The oceans of Earth have been drinking in sunlight for 4.5 billion years. They are full of it. Even without a sun, the oceans would stay above freezing for hundreds, perhaps even thousands of years in their deepest, warmest parts. The sea remembers the sun in a way that rock and air simply cannot. This is why so many of the most fascinating and mysterious creatures on Earth already live as if the sun doesn't exist. Deep ocean life, the creatures that dwell thousands of meters below the surface where no light has ever reached, have been living in permanent darkness for all of their existence. They do not miss the sun because they have never met it. They live by geothermal heat, by the warmth that seeps up through the ocean floor, from the Earth's own interior, from the slow turning of our planet's molten heart. And this is important because the Earth's core, that great burning center, as hot as the surface of the sun itself, would not be affected at all by the sun's absence. The Earth makes its own heat from within. It always has. Let your breath slow down again now. Feel the weight of your body, warm and still, held up by whatever you are resting on. The ground beneath you, beneath your home, beneath your city, beneath the ocean floor, is warm. It has been warm for 4.5 billion years. That warmth does not come from the sky. It comes from the center of things, from the slow decay of radioactive elements deep inside the Earth, from the original heat of formation, from the pressing together of all that matter so long ago. You are, in a way, resting on a slow-burning ember that will take billions more years to cool. You are warm because the Earth is warm, because the universe is generous with its heat in ways we rarely stop to think about. The moon, of course, would still be there. It does not make its own light. It reflects the sun's. So, without the sun, the moon would become dark, invisible in a sky full of stars. No more silver light through the curtains at night. No more soft shadows on the grass. But the moon's gravity would still be exactly as it always was. The tides would still come and go. The ocean would still breathe in and out against every shoreline in the world, just as it has for billions of years, pulled by the moon's quiet, faithful presence. Tides are one of the most ancient rhythms on Earth. Even in the dark, even in a world without sunlight, the ocean would still keep time. And with that image, the dark ocean still breathing, still rising and falling, still faithful to the moon, let yourself breathe too, in and out. Let the rhythm be something you don't have to think about. Just notice it gently. Your body knows how to breathe the way the ocean knows how to move. It does not require instruction or effort. It simply does what it has always done, because it is alive, because it is warm, because it is part of a world that has been keeping this rhythm for longer than we can comfortably imagine. In the months following the sun's disappearance, the surface of the Earth would gradually freeze over. This sounds stark, but consider it softly. The snow and ice that would cover the land would be some of the most beautiful and quiet landscapes in Earth's history. A world of white, lit only by stars, by the aurora borealis, which would still dance in the sky, fed by the Earth's own magnetic field interacting with the solar wind, which would continue for a while, as the last gasps of the sun's energetic past caught up with us. Those northern lights, those southern lights, they would blaze without competition from any moon, without any city glow below, painting the frozen sky in greens and pinks and violets that you could fall into. The aurora is caused by charged particles from the sun interacting with Earth's magnetic field. Even without the sun actively shining, the solar wind, the constant stream of particles the sun has been blowing outward for billions of years, would take time to fade. The particles already traveling through space would continue to arrive for months. So the auroras would continue, perhaps even intensify in their colors in the crystal clear, unpolluted air of a world without industry running at full capacity. Imagine the most beautiful light show you have ever seen spread across the entire sky. In a world so quiet and still, you could hear your own heartbeat. Below the frozen surface, though, something surprising would remain alive. Not just in the oceans, on the land too. Geothermal vents, hot springs, volcanic regions. These would become islands of warmth in a cold world. Places like Iceland, Yellowstone, the Kamchatka Peninsula in Russia, the volcanic islands of the Pacific. These places are heated from below, from the Earth's interior, and they would remain warm and liquid even in a sunless world. The hot springs of Iceland, which today are a luxury, a treat, a place where people soak in warmth and look up at the sky. In a sunless world, they would become something even more precious. Pockets of warmth, gathering places gentle and alive. Before we drift on into the deeper parts of this story, do take a moment, if you're finding this soothing and interesting, to check out the Sleepy Science playlist. There are many other quiet journeys there waiting for you. The deep ocean, the formation of stars, the science of sleep itself. Each one is made with the same care and the same intention, to give your mind something gentle and true to rest upon as you drift toward sleep. Plants, as you might imagine, would face the most immediate challenge. They live on light, or more precisely, on a process called photosynthesis, which is just a gentle word for the way a leaf turns sunlight into food. Without sunlight, most plants would begin to slow down very quickly. Within days, photosynthesis would stop. Within weeks, most surface plants would begin to die. This sounds sad, and in one way it is, but nature has held survival strategies in its pocket for as long as life has existed. Seeds, for instance, are extraordinary things. A seed is one of nature's most patient inventions. Inside a seed, everything needed to become a tree, a flower, a field of grain, is held in a state of suspended waiting. Seeds can survive extraordinary conditions, freezing, drying, darkness. Some seeds found in archaeological digs have been thousands of years old and have still managed to sprout when given water and warmth. There are seeds in seed banks around the world, kept frozen and safe, waiting with a patience that has no human equivalent. If warmth returned to the earth someday, from geothermal sources, from clever human engineering, from whatever slow miracle the future held, seeds would be ready. They are always ready. They do not lose hope. They simply wait. Life at the bottom of the ocean would not even notice the change, not really. Hydrothermal vents, those remarkable cracks in the ocean floor where superheated water rich in minerals bubbles up from the Earth's interior, support entire ecosystems that have never needed the sun. Tube worms meters long, ghostly white crabs, shimmering clouds of bacteria, fish with no eyes who navigate by pressure and chemistry. These communities are fed by chemosynthesis, not photosynthesis. They eat the chemicals that rise from the earth rather than the light that falls from the sky. They are proof that life does not require a star. Life requires only warmth and chemistry and a little bit of time. Scientists believe that life on Earth may have actually begun near hydrothermal vents billions of years before the first photosynthetic organism ever looked up at the sun. Life, in a sense, started in the dark. The sun came later as a bonus, a gift, an extraordinary windfall that allowed life to diversify and spread across the entire surface of the world. But the original home of life, the first hearth, was deep and dark and warm, much like the feeling you might have right now, tucked in, quiet, at rest. Let yourself feel that warmth around you. Your body generates heat all on its own, just like those hydrothermal vents, just like the Earth's core, warmth coming from the inside, from the chemistry of being alive, from the slow and remarkable process of being you. You do not need the sun to be warm right now. You already are. The temperature on the surface of a sunless Earth would keep falling through the first year. By the end of year 1, it would likely be around negative 70 degrees Celsius in most places. Brutally cold by human experience. The kind of cold found at the South Pole in winter. But deep underground, even just a kilometer or so below the surface, the temperature stays relatively constant year-round, warmed by the Earth's own interior. Underground caves, deep mines, underground aquifers. These spaces maintain livable temperatures even when the surface is glacial. Some of the most remarkable human engineering feats in history have involved going underground. The ancient Qanat water systems of Persia, the cave cities of Cappadocia in Turkey, the underground salt cities of Eastern Europe that have existed for centuries. Humans are remarkably adaptable. We have lived in deserts and tundras, on mountains and in jungles, above the Arctic Circle and in tropical rainforests. We have survived ice ages before, not the same kind, but cold, hungry times when the glaciers pressed down from the north and the world was harder and colder. And we made it through, not just barely, but creatively. We painted cave walls. We told each other stories. We kept fires and kept warm and kept going. There is something very deep in human beings, maybe in all life, that holds on, finds warmth, finds a way forward through the dark. The thought of going underground might make you think of coziness, actually, of warmth and enclosure, of being held by the earth rather than exposed to it. The feeling of being inside on a cold night is one of the oldest comforts humans know. The fire inside, the cold outside, the walls between. You might feel something like that right now, the quiet pleasure of being contained and warm while the wider world does whatever it does. That contrast, warm inside, dark outside, is as old as human existence. It is built into us. Astronomers and planetary scientists have a beautiful concept called the habitable zone, sometimes called the Goldilocks zone, the region around a star where conditions might be just right for liquid water to exist. Not too hot, not too cold. Earth sits comfortably in the sun's habitable zone. But in a sunless Earth, something interesting happens. Our planet becomes its own kind of habitable zone, defined not by distance from a star, but by distance from the Earth's own center. Deep enough underground, you find warmth, with water, with geothermal energy, with the chemistry of the Earth's interior. Habitable conditions could persist for an extraordinarily long time. Some scientists have calculated that geothermal energy alone could sustain microbial life on Earth for billions of years, even without a sun. Billions of years. That is longer than the sun has even existed. Life, once it begins, is remarkably difficult to end completely. It finds the margins, the edges, the deep and dark places where warmth persists. It is stubborn in the best possible way. Not aggressive, just quietly persistent. The way a plant finds the single crack in the pavement and grows there. The way water finds its way through rock given enough time. The stars, remember, would be extraordinary. In a sunless earth, with no daytime sky to compete with, and with gradually diminishing artificial light as energy sources were redirected and rebuilt, the night sky would become a constant companion. Human civilization has always navigated by stars. For thousands of years, before GPS, before maps, before written language, people looked up and found their way by the patterns in the sky. The constellations are, in a way, humanity's oldest story. The Big Dipper, Orion, the Southern Cross. These have been looked at and named and loved for as long as people have been looking up. In a sunless world, the sky would be full of these old friends all the time, not just at night, but always. The planets of our solar system would still be visible, Jupiter's great steady brightness, Saturn's soft glow. Without the sun's overwhelming light, we might even see things that are normally hidden in the daytime sky. Faint nebulae, the smudgy glow of nearby galaxies, the arc of the Milky Way overhead at all times. The sky would become a ceiling of living light, constant and patient, something to navigate by and wonder at and fall asleep beneath. And if the starlight, or this story, has given you something pleasant to rest your thoughts on, do please leave a comment below. We love to hear from you, your favorite facts, the images that lingered, the moments where you felt something shift and soften. Your words mean more than you know. One of the most quietly spectacular things that would happen in a sunless solar system concerns the other planets. Without the sun's light, they would gradually become invisible to the naked eye. No reflected sunlight to make them glow. But they would still be there, following their ancient paths, held in their orbits by the lingering dance of gravitational forces. Mercury and Venus, closest to where the sun was, would drift free first, released from their tight orbits within months or years of the sun's disappearance. Jupiter's massive gravity would reach out and begin to influence things slowly over millions of years. But let's not think in millions of years tonight. Let's think in quiet moments. Let's think about right now and the fact that you are listening to this, breathing softly, resting. Right now, the Earth is turning. It turns about once every 24 hours, has been turning for 4.5 billion years, will keep turning for billions more. That turning is independent of the sun. The sun did not make the Earth spin. The Earth was spinning when the sun was still a cloud of gas. The rotation of our planet is its own ancient momentum, a habit formed in the earliest days of the solar system's formation, and it will persist long after the sun is gone. The Earth would spin in the dark. The tilt of its axis, that 23.5-degree lean that gives us our seasons, would remain. Seasons in a sunless world would lose their meaning in terms of temperature, but the Earth would still tilt and turn with the same faithful consistency. There is something deeply reassuring about that. Some things simply continue. Some rhythms are so deeply set that even the loss of the thing that started them does not stop them. You are like that too, in a way. Your heart has its rhythm. Your lungs have their rhythm. Your sleep and waking has its rhythm. These cycles were set in motion long ago, and they carry you through each day without you needing to think about them. You are a self-sustaining system of warmth and rhythm, just like the earth. You were made to keep going gently through the dark as well as the light. As weeks turn to months in our imagined sunless world, something beautiful would happen to the frozen surface of the earth. In places where volcanic activity continued, and volcanoes are common enough, there are hundreds of active ones today. The ice would meet fire in landscapes of extraordinary strangeness and beauty. In Iceland, which sits atop a volcanic hotspot, there are already places where geysers erupt through snow and ice, where rivers of lava cool into black glass just meters from a glacial field. In a sunless world, these contrasts would become more dramatic, more present, more alive. The steam rising from a hot spring into freezing air creates a fog, a mist that hangs low and soft over the landscape. In that mist, on the edge of warmth and cold, extremophile bacteria, tiny life forms that thrive in extreme conditions, would be perfectly at home. They already are. Right now, in the hot springs of Yellowstone, there are bacteria living at temperatures that would cook most life instantly. In the near-freezing waters of Antarctic lakes, there are bacteria that thrive in conditions that would kill most organisms in minutes. Life has found every margin. Life will be there in the cold, hot margins of a sunless Earth, too. Extremophiles are one of the great joys of biology, if you ask me. They challenge the idea that life is fragile, that it requires specific and narrow conditions to survive. They show us that life is more of an attitude than a recipe. Give chemistry the right elements and a little energy, any kind of energy, light, heat, chemical, and given enough time, something will figure out how to use it. Something will find a way to grow, to reproduce, to persist. The universe is full of energy in many forms, and life is very good at finding it. The comets and asteroids of our solar system, those frozen wanderers that orbit in the dark reaches of space, would also continue their slow journeys after the sun vanished. Some of them carry water ice, amino acids, the building blocks of proteins, and complex organic molecules. Scientists have found evidence that some of the water on Earth, and perhaps some of the chemical precursors to life itself, arrived on early Earth via comets billions of years ago. The universe distributes its ingredients broadly and generously, carried on dark travelers through the black between the stars. In a sunless solar system, these travelers would still be out there, drifting. The Oort cloud, that vast distant shell of icy objects that surrounds the outer reaches of our solar system, far beyond even Pluto, contains trillions of these objects. They are so far away that the sun barely holds them. In a sunless system, many of them would eventually drift free, becoming interstellar objects, traveling between the stars. Some would drift for millions of years before encountering another star system, carrying their frozen cargo of molecules through the deep quiet of space. Life's ingredients, out for a very long journey. This is a good time to let your body be very still. Notice the quiet around you, your breathing slow and easy, the weight of your limbs, the warmth of wherever you are resting. You are, in this moment, exactly where you need to be, warm, still, held by the earth, lit from within. Let the images drift, frozen landscapes and hot springs, stars filling the whole sky, the earth turning faithfully in the dark, seeds patient in their banks, life at the bottom of the ocean going about its quiet business as it always has. Let the next part of this story find you even more relaxed than you are now. The sun, it turns out, was not always going to be with us anyway. This is not a sad thought. It is a very ancient one, and there is something calming about it. Our sun is a middle-aged star, about 4.5 billion years old, with roughly another 5 billion years to go before it begins to change significantly. When it does change, it will not go out. It will grow. It will slowly expand into a red giant, swelling outward until it encompasses Mercury, then Venus, and perhaps Earth as well. But that is so far in the future that the number barely has meaning. 5 billion years. For context, the first single-celled life appeared on Earth less than 4 billion years ago. The universe has time to spare. Stars are born from clouds of gas and dust, and they live for millions or billions of years, depending on their size. And then they die in their own particular ways. Small stars like our sun fade into white dwarfs, tiny, dense, incredibly hot remnants about the size of Earth, no longer fusing hydrogen but glowing with leftover heat for billions of years more. A white dwarf cools so slowly that the largest, oldest ones are still too warm to measure precisely. They are the embers of a universe that has been burning for almost 14 billion years. Larger stars, though several times more massive than our sun, end their lives in supernovae, vast explosions that scatter the star's material across light years of space. And within those explosions, new elements are forged. The carbon in your body, the iron in your blood, the calcium in your bones. All of this was made inside a star that died before our solar system was born. You are, in the most literal scientific sense, made of stardust. Every heavy element in your body was forged in stellar fusion and scattered by a stellar death before it found its way here, to this planet, to this moment, to you. There is a kind of peaceful enormity in that. You have been part of this universe for as long as the universe has been making the elements you're made of. You are not a newcomer. You are not a brief visitor. You are a continuation of something that started nearly 14 billion years ago, a particular shape that the universe has taken for a little while. Your atoms have been through stars. Your molecules have drifted through space. You are a very old thing, wearing a very new arrangement. Let that thought settle into you gently. You are made of ancient material. You are held by an ancient planet. You are resting in an ancient rhythm of day and night, warmth and cool, waking and sleep. Nothing about this moment is accidental. It is the result of billions of years of the universe arranging itself into increasingly interesting shapes. And right now, the shape it has taken is you listening to this, at rest. As the surface of our imagined sunless Earth grew colder and quieter, the atmosphere itself would begin to change. Slowly, over years and decades, some of the gases in our atmosphere would condense. Nitrogen, which makes up about 78% of our air, would stay gaseous for a very long time, as its boiling point is extremely low. Oxygen would last too, but water vapor would freeze out of the air, settling as snow. Carbon dioxide, which at Earth's current concentrations is a minor component of the atmosphere, would eventually freeze and fall as dry ice snow at around minus 78 degrees Celsius. the last gasps of our atmosphere, long after humanity had reorganized itself underground or near geothermal sources, would be an extraordinary sight. A sky gradually stripped of clouds, of haze, of weather, because weather, as we know it, is driven by the sun. Without solar energy warming different parts of the earth at different rates, the great winds and storms and weather systems would slow and then stop. The atmosphere would go very still, without convection, without the differential heating that drives all weather. The air would simply sit quiet and cold above a frozen world. This stillness, the absence of weather, is actually one of the most alien things to imagine. We are so accustomed to wind, to the movement of air, to the feeling of weather happening around us, that we barely notice it anymore. But wind is essentially the sun's breath, the sun pushing warm air up and pulling cool air in from the sides, creating movement. Without the sun, the air would stop moving. Perfect stillness. Silence so complete that you might hear your own thoughts more clearly than you ever have. Does that sound frightening, or does it sound peaceful? I find it peaceful, actually. A world finally, completely still. Stars above, ice below, and the quiet hum of the earth's own warmth somewhere beneath your feet. There are worse things to imagine as you are falling asleep. And if you are feeling that particular pleasant heaviness that comes just before sleep, that is good. That is the point. We are building a nest of thoughts here, warm and soft. Let yourself settle into it a little more. The geothermal regions of a sunless Earth, Iceland, Yellowstone, the Azores, Kamchatka, the East African Rift, would become the new gardens of the world. Near these warm places, life would gather and adapt. We already see hints of this in today's world. The springs around Yellowstone are host to organisms that color the water in rings of orange and yellow and green. Thermophilic bacteria, lovers of heat, painters of hot pools. The cave systems near volcanic regions contain their own private ecosystems, fed by minerals rather than sunlight, complete and self-sufficient. Underground rivers, aquifers that flow through rock for hundreds of kilometers, would carry warmth from geothermal zones outward. Water, again, holds heat so beautifully. These underground rivers would be warm, in some cases almost hot, threading through the darkness of the Earth's crust like veins of warmth, like the circulatory system of a living world. Some cave fish in the world today are already adapted to these underground rivers, pale, eyeless, navigating by vibration and chemical sense, perfectly content in their cool, dark, flowing homes. In a sunless world, they would be among the inheritors. Eyelessness is a fascinating adaptation. Many cave-dwelling animals have lost their eyes over evolutionary time. Because eyes are expensive, they require significant biological resources to build and maintain. And if there is no light, they provide no benefit. So, gradually, over many generations, the creatures that happened to have slightly smaller eyes did just as well as those with larger ones, and eventually eyes disappeared from these lineages entirely. It is not that the creatures went blind. It is that sight became irrelevant, and biology, always practical, stopped spending energy on it. Other senses filled the space. Cave fish sense their surroundings through the lateral line, a system of pressure-sensitive cells along their bodies that detect tiny vibrations and movements in the water. They sense the presence of prey, of obstacles, of each other, through what amounts to a kind of feeling at a distance, an awareness without sight. In a sunless world, life would find new senses, new ways of perceiving, new intelligences tuned to the information that was actually available. We already have more senses than we usually think about. Beyond sight and hearing and touch and taste and smell, we have proprioception, the sense of where our bodies are in space, and vestibular sense, which gives us our feeling of balance. We can feel temperature, feel pain, feel the stretch of a muscle. We sense time passing, sense when we are hungry or tired, sense social signals from others through very subtle cues. In the dark, these other senses would come forward. The world would be perceived differently, felt rather than seen, heard rather than watched. Close your eyes now, if they're not already closed. Notice what you can still perceive, the weight of your body, the temperature of the air, the sound of your breathing, or perhaps the sounds of the world around you settling into night, the feeling of the surface beneath you. You are already sensing so much without your eyes at all. You are already living a little in the dark and finding it comfortable. Let me tell you about the other planets, because they are beautiful to think about in the dark. Mars, our near neighbor, would also go cold and dark. It is already cold, minus 60 degrees on an average day, with a thin atmosphere that does little to hold warmth. Without sunlight, Mars would freeze even its traces of carbon dioxide more completely. It would become quieter, more still, a red world turned brown-black in the dark. But Martian geology is not finished. There is evidence of past volcanic activity on Mars, and some researchers believe there may still be geothermal heat beneath its surface. Even Mars in the dark might hold a small warmth somewhere deep inside. Jupiter would remain extraordinary. It is a gas giant, a world so large that 1,000 Earths could fit inside it. And it generates more heat from its own interior than it receives from the sun. Jupiter is slowly contracting, releasing gravitational energy as heat, and it radiates more warmth than it absorbs. In a sunless solar system, Jupiter would become a dim, self-heating world, a faintly glowing coal in the outer darkness surrounded by its moons. Europa, one of those moons, has a global ocean of liquid water beneath its icy surface, kept liquid by the tidal heating caused by Jupiter's gravity. Even without the sun, Europa's ocean would remain. Scientists consider it one of the most promising places in the solar system to look for life. Consider that for a moment. A moon orbiting a planet that generates its own heat, with an ocean under ice that has probably never seen sunlight and may have been liquid for billions of years. Life may already be there, swimming in that dark water, completely unaware of the sun, never having needed it. If life can exist in Europa's ocean, then losing the sun would not end life in our solar system. It would just change where we need to look for it. This is one of the most profound things that thinking about a sunless world reveals. Life does not belong to the sun. Life belongs to warmth and chemistry and time. The sun was extraordinarily generous in providing all three in abundance, and we are deeply fortunate children of that generosity. But the deeper truth, the older truth, is that life is more fundamental than any single star. It finds its way. It is already finding its way in oceans under ice, in deep sea vents, in the rock itself, in places we have not yet thought to look. You might like to wander into the Sleepy Science playlist after this. There is a whole journey there, about the moons of Jupiter and Saturn, about what it might be like to stand on Europa and look up at Jupiter filling the sky. Each video is exactly like this one, slow, quiet, made for the space between waking and sleep, full of things worth knowing and gentle enough to drift away with. The concept of time without a sun would become very strange for human psychology. Our experience of time is deeply tied to the rhythm of light and dark, to the day and night cycle that the Earth's rotation gives us. Our brains evolved in that rhythm. Our bodies run on it. The circadian rhythm, from the Latin words meaning approximately a day, governs not just when we sleep and wake, but when our hormones peak, when our body temperature rises and falls, when our immune system is most active, when our minds are sharpest. It is a clock that lives inside every cell of your body, running on roughly 24-hour cycles, synchronized to the light of the sun. Without sunlight, this internal clock would continue running, but it would gradually drift. Experiments where people have lived without any light cues at all, in caves or windowless rooms, show that the human circadian rhythm settles into a cycle slightly longer than 24 hours, around 24 to 25 hours for most people. Without the sun to reset it each day, we would gradually drift out of sync with each other. Some people would want to sleep when others were wide awake. The shared social clock of the day would slowly dissolve. But humans are also extraordinarily adaptable. We would find new cues to synchronize by: shared meals, social interaction, artificial light of our own making. In underground communities, we would create our own light cycles, our own rhythms, our own shared sense of time. We have done this in extreme environments before. Antarctic researchers who lived through months of polar night, submarine crews who maintained strict artificial day-night cycles, cave explorers who go weeks without natural light. We adapt. We bring our rhythms with us and we create new ones when needed. Your own sleep rhythm right now is a beautiful thing. Your body knew, even before you lay down, even before you pressed play, that sleep was coming. Your core body temperature began to drop. Melatonin began to rise in your bloodstream. Your brain began the long, slow process of consolidating the day's memories, sorting them, filing them, letting some go. You were already beginning to sleep before sleep arrived. The body is always ahead of the moment, already preparing, already leaning toward what comes next. Let it do that now. Let the preparation for sleep that has already begun simply continue. You don't have to do anything. Your body knows exactly what to do. In the deep underground of our imagined sunless Earth, there would be something else extraordinary happening: bioluminescence. This is the ability of living organisms to produce their own light, and it is already one of the most wondrous things life does. Deep-sea creatures, fish, jellyfish, squid, bacteria, produce light through chemical reactions in their bodies. Some use it to attract prey, some to communicate, some simply as a byproduct of their chemistry. In the ocean, more than 70% of deep-sea organisms produce their own light. This living light, this cold glow that life makes for itself, would be one of the most beautiful things in a sunless world. In the dark ocean, it already is. There are creatures in the deep ocean whose bodies pulse with blue and green light, whose tendrils trail sparks, whose eyes glow like tiny lanterns. The deep ocean is not dark the way we imagine. It is dark with sunlight, but it is full of biological light, soft and shifting and alive. In a world without a sun, the creatures that already carry their own light would inherit the dark with particular grace. Some surface organisms are also bioluminescent. Fireflies, of course, those perfect small summer magics. Some mushrooms and fungi glow faintly green in the dark. Certain bacteria, when they reach high enough densities, make bioluminescent seawater. The famous blue waves of bioluminescence seen in warm tropical bays, where the water itself seems to glow with every movement. In a sunless, cooling world, as life reorganized and adapted, the organisms capable of producing their own light might become more prevalent. A world without sunlight might gradually fill with a different, softer, more intimate light, the light that life makes for itself. Think of a firefly on a warm evening, the pulse of its light, unhurried, private, a small lantern floating through summer dark. That kind of light, soft, alive, made from within, is exactly the kind of thing to carry into sleep. Not the great blazing sun, generous but overwhelming, but the quiet, self-made glow of a creature finding its way through the dark on its own terms. You are warm. You are quiet. You are doing exactly what life has always known how to do, finding comfort in the dark, resting when the light is gone, trusting that you will still be here when light returns in whatever form it takes. One of the most interesting scientific questions around a sunless Earth concerns the ice that would cover the surface. Ice is not simply frozen water. It is a material with its own remarkable properties, and one of the most important is that it reflects light. Scientists call this albedo, the measure of how much light a surface reflects rather than absorbs. Fresh snow has an albedo of around 80 to 90%. It reflects most of the light that hits it. Dark ocean water, by contrast, absorbs almost all the light that reaches it. On a sunless Earth, this property would no longer matter in terms of heating, since there would be no incoming solar radiation to reflect or absorb. But as a historical curiosity, it is interesting to note that Earth has been through periods of extreme glaciation before. Events scientists call snowball Earth, when the entire surface of the planet may have been covered in ice for millions of years. These events happened multiple times, hundreds of millions of years ago, and life survived them. Not easily, not without cost, but it survived. Somewhere in the dark ocean beneath the global ice, life held on, waited, kept its chemistry going. What ended the snowball Earth periods was volcanic activity. Carbon dioxide building up in the atmosphere over millions of years until the greenhouse effect warmed the planet enough to melt the ice from the inside. Even in those frozen times, the Earth's interior was still working, still breathing carbon dioxide into the sky, still keeping its slow promise of eventual warmth. The Earth has always been on life's side, in a way. Or perhaps more accurately, life has always found a way to be on the Earth's side, to fit into the world as it is, rather than the world as it might ideally be. This is one of the most comforting things that the history of life teaches. It works with what it has. A volcanic world, a snowball world, a world battered by asteroids, a world with an atmosphere that was once mostly methane and carbon dioxide rather than nitrogen and oxygen. In each of these worlds, life found a configuration, a chemistry, a way. The history of life is the history of adaptation. every creature alive today is the end of an unbroken chain of survival stretching back billions of years. You are the product of every ancestor that managed to eat, to stay warm, to rest when rest was needed, to keep going. You come from a very long line of survivors. You carry that in your biology, in the very structure of your cells. Tonight, right now, you are surviving very gently, breathing, resting, doing exactly the thing your body was designed to do in the dark. In the far future of our sunless Earth, centuries or millennia out, the surface would be uniformly frozen, a white and silent world. But beneath the ice, the geothermal warmth would create an extraordinary feature, a layer of liquid water between the rock below and the ice above. This is exactly what we believe exists beneath the ice of Europa, of Enceladus, of Titan. Earth, in a sunless far future, might become something like those worlds, an ocean world under ice, with its own chemistry, its own heat, its own quiet and persistent form of life. Enceladus is one of Saturn's moons, and it is one of the most exciting places in the solar system to dream about. It is a small, icy world, and it has geysers, actual geysers of water vapor and ice crystals erupting from cracks near its south pole, shooting material out into space, forming part of Saturn's rings. Beneath Enceladus's icy surface, there is a liquid ocean. The Cassini spacecraft flew through those geysers and detected organic molecules, salts, and hydrogen, the products of water reacting with hot rock deep within the moon. If life exists on Enceladus, and scientists genuinely believe it might, it lives in that dark ocean, fed by geothermal chemistry, having never needed a sun. The solar system, it turns out, is full of dark oceans. Beneath the ice of Europa, Enceladus, Ganymede, Callisto, Titan, each of these moons may harbor liquid water, warmed by gravity and internal heat. The sun's habitable zone, the narrow band of space where liquid water is possible on a surface, turns out to be just one of many ways to be habitable. The real habitable zone might be anywhere you find warmth and water, and warmth and water exist in the most unexpected places. Our own ocean covers about 71% of Earth's surface, and we have explored only a small fraction of it. The deep ocean, deeper than 2,000 meters, makes up about 95% of the total volume of all Earth's oceans, and it is more poorly mapped than the surface of Mars. Down there, in that vast, dark volume of cold, salt water, are mountain ranges taller than the Himalayas, plains wider than any continent, trenches deeper than the height of the sky above us, and in all of it, life, strange, patient, remarkable life. The Mariana Trench, the deepest point on Earth, about 11 kilometers beneath the surface, is home to creatures adapted to crushing pressure, perpetual cold, and total darkness. Amphipods, small crustaceans that look like shrimp, live at the very bottom and have been found with plastic in their bodies, which is a sadder thought than we need tonight. But the life itself is extraordinary. They eat marine snow, the constant slow drift of organic particles falling from the surface, and in turn are eaten by things we have not yet named or described. The deep ocean contains species that have never been seen by human eyes. Let the thought of the deep ocean carry you a little deeper into rest. That vast, dark, quiet, cold, teeming world, the slow movement of water over cold rock, the occasional flash of bioluminescence in the distance, the sense of immense depth below and above, and somewhere in between, you, warm, still, breathing. If there is a song playing softly somewhere, or just the quiet of your room, let it be like the pressure of deep water, not pressing, just present, surrounding. You are held. There is a particular quality of quiet that belongs only to snow. You may know it. That muffled, softened hush that falls over the world when everything is white, when sound seems to travel shorter distances, when even your own footsteps become something private and contained. This happens because fresh snow is full of air pockets, and those tiny pockets absorb sound rather than reflecting it. Snow is a natural acoustic dampener. A snowfall is, in the most literal physical sense, the world going quieter. And in a sunless earth covered over time in a deep and undisturbed blanket of snow and ice, the world would be quieter than it has ever been in the history of life on this planet. Sound needs a medium to travel through. Air, water, solid material. It does not travel through a vacuum. In space, there is no sound at all, which is one of the reasons space feels so alien to imagine. We are beings of sound. We orient ourselves by it. We find comfort in it. But on the surface of a frozen earth, with the wind finally still, because wind, as we explored earlier, is a product of the sun's uneven heating, the only sounds would be geological ones. The deep groan of ice sheets settling, the distant rumble of a volcano far away, the creak of rock expanding and contracting with the slow rhythm of geothermal heat below and cold above. The earth making its own quiet music with no audience but the stars. Ice has its own language, and it is one of the most beautiful and least studied in the world. When glaciers move, and they do move slowly, the way time itself moves, imperceptibly in any single moment, but undeniably over longer spans, they produce sounds that researchers describe as groans, sighs, and deep musical notes. Some glaciologists have recorded the sounds of Greenland's ice sheet and found frequencies so low they fall below what human ears can detect. Infrasound, the sub-bass of the frozen world. These sounds travel great distances through the ice and through the rock below. In a sunless world, deep underground, you might feel more than hear the voice of the frozen surface above, a slow, fast vibration coming down through the rock, telling you that something enormous and patient is shifting overhead. The ice itself, as it builds up over years and decades and centuries, becomes a record. This is one of the most wonderful things about ice. It remembers. Each year, a new layer of snow falls and compresses the layer below. And in that compression, it traps tiny bubbles of whatever the atmosphere was like at that moment. These air bubbles are time capsules. Scientists drill ice cores, long cylinders of ancient ice, from the glaciers of Antarctica and Greenland, and when they analyze the bubbles inside, they can read the composition of Earth's atmosphere going back hundreds of thousands of years. They can find the fingerprints of ancient volcanic eruptions, of ice ages, of warm periods, of every significant thing that ever happened to the atmosphere. In a sunless world, the ice that built up over the surface would be an extraordinary archive. Every year of the sunless age would be preserved in layers, like the pages of a book written in cold and silence. Future scientists, if there were any, perhaps from another civilization visiting long afterward, could drill into that ice and read the entire story of what happened. The year the atmosphere changed, the year the last storm blew, the year the carbon dioxide began to freeze out of the air, the year the last surface warmth faded. The ice would remember everything, patient and precise, the way the earth always remembers things that we imagine are lost. There is something deeply settling about the idea that things are not truly lost, just stored in a different form. The energy of the sun, absorbed by the oceans over billions of years, becomes warmth that persists for centuries. The history of the atmosphere, seemingly gone with each passing year, preserved in ice. The songs of ancient glaciers held in the vibrations of rock. The universe is an extraordinary keeper of records. Nothing is simply erased. It is changed in form, moved to a different layer, held in a different medium. Even light traveling outward from a vanished sun would continue forever, diminishing, spreading, but never fully gone, carrying its information across the universe until something, somewhere, absorbs it. Breathe easily now. Think of yourself as one of the things the universe is keeping. Your warmth, your weight, your breathing, all of it is real and present and held in this moment, which is itself a layer in the great archive of time. Right now, this breath, this quiet, it is happening, it is real, and in the way that physics keeps everything, it will always have been real. This moment is permanent in the only way that matters. It is occurring, and nothing can unmake its having occurred. That is a gentle thought to carry into sleep. Water, in all its forms, is one of the great wonders of chemistry, and in a sunless world it would continue to move and transform in ways that are quietly beautiful to think about. Even under ice, water moves. Subglacial lakes, lakes of liquid water, trapped beneath kilometers of ice, warmed from below by geothermal heat, exist right now on Earth, beneath the Antarctic ice sheet. Lake Vostok, the largest known subglacial lake, is buried under nearly 4 kilometers of ice and has been isolated from the surface for at least 15 million years. It is dark, cold, and under enormous pressure, and it is full of life. Bacteria adapted to those specific conditions thrive in it. They have been there, in that buried lake, for longer than our species has existed. In a sunless Earth, the number and size of subglacial lakes would grow over time. As ice sheets built up above geothermal regions, meltwater from below would accumulate, pooling in the hollows of the bedrock, growing slowly from rivulets into rivers, into lakes, into, eventually, connected networks. A subglacial world of water, moving in total darkness beneath a skin of ice that was itself kilometers thick. This hidden hydrosphere, a water world within the world, would be one of the most extraordinary features of a sunless Earth. Warm, dark, mineral-rich, pressurized, everything that life needs, packaged in the most unexpected way. The minerals that geothermal vents release into these subglacial waters would be astonishing in their variety. Iron, sulfur, manganese, calcium, silica, the building blocks of shells, of bones, of every hard structure that life has ever invented. In the deep ocean today, creatures use these minerals in remarkable ways. Tube worms build calcium carbonate tubes, snails near vents have iron-plated shells, sponges build intricate silica lattices, more delicate than any human-made glass. Life is an extraordinary chemist. Given the right ingredients and enough time, it builds structures of breathtaking complexity and beauty from the raw material of the Earth's interior. The thought of a snail with iron-plated scales living near a deep-sea vent is one of those facts that feels almost too strange to be true, but it is perfectly real. The scaly-foot snail, found near hydrothermal vents in the Indian Ocean, has a foot covered in iron sulfide scales, the only known animal to incorporate iron sulfide into its body armor. It lives in water hot enough to kill most organisms, at pressures that would crush an unprotected human, in total darkness, eating bacteria. It is, by any ordinary definition, thriving. It is one of the most alien-looking creatures on Earth, and it lives here, right now, in the dark depths of our own ocean. You don't have to travel to another world to find life that belongs to the dark. It is already here, already going about its quiet and improbable business. If any of these strange and beautiful creatures have found their way into your imagination tonight, the iron-scaled snail, the tube worm in its white tower, the eyeless fish pressing through the dark, do share a thought below in the comments. This community gathers around exactly these kinds of images, the unexpected, the tender, the quietly astonishing things that science finds when it looks closely at the world. And the playlist is always there for you, full of more worlds like this one to visit on another quiet night. Let your body be very still for a moment, heavy and warm and still. The subglacial lake is there, somewhere far below, going about its patient business. The iron-scaled snail is doing exactly what it has always done. You are doing exactly what you have always done in the dark, which is rest, which is breathe, which is trust that the warmth will still be there when you need it. One of the things a sunless Earth would eventually teach us if we were paying attention is how much of what we consider essential is actually circumstantial. Sunlight is essential for photosynthesis, and photosynthesis is essential for the food web that most surface life depends upon. But remove that chain of dependencies, and what remains is not nothing. It is a different kind of life, built on different foundations, no less real and no less vital. This is one of the most profound things that astrobiology, the science of life in the universe, has taught us in recent decades. Life is not defined by its ingredients. It is defined by its processes, and those processes are more flexible than we ever imagined. Tardigrades are perhaps the most famous example of this flexibility. These tiny animals, also called water bears, which is possibly the most charming name in all of biology, are about 0.5 millimeter long and live in moss, in soil, in the thin film of water, on plants, in the deep ocean, in hot springs, in Antarctic ice. They have been found in the Himalayas and in ocean trenches, in tropical rainforests, and in polar deserts. They can survive temperatures from near absolute zero to 150 degrees Celsius. They can survive radiation doses that would kill any other animal many times over. They can survive the vacuum of space. They do this by entering a state called cryptobiosis, a kind of extreme suspended animation in which they retract their limbs, expel almost all water from their bodies, and essentially stop all metabolic activity. In this state, they can survive for decades, perhaps centuries, waiting for conditions to improve. A tardigrade in cryptobiosis is one of the most peaceful images in biology. This tiny creature curled into itself, almost nothing happening inside it, waiting, not with anxiety, not with urgency, but with a kind of biological patience that makes human impatience feel very young by comparison. It is not asleep exactly. It is not anything exactly. It is in between. And when the right conditions return, moisture, a livable temperature, the chemistry it needs, it simply resumes, unfolds, goes back to being a water bear, going about its tiny water bear life as if no time has passed at all. In a sunless world, tardigrades would be among the last survivors on the surface, lasting far longer than anything larger or more complex. They are already on every continent, in every environment, in numbers that are difficult to comprehend. 1 square meter of moss can contain hundreds of thousands of them. The world, right now, is full of tardigrades in their quiet lives. And if the sun vanished, they would tuck themselves in and wait, as they always have, with a patience that outlasts stars. There is a kind of meditation in that, the capacity to simply pause, to stop requiring things from the world, to reduce yourself to the barest essentials, and trust that you will still be you when it's over. We do a version of this every night. Sleep is not so different from cryptobiosis. It is a voluntary reduction of activity, a turning inward, a trust that the world will still be there, and that you will still be you when you wake. Your body asks less of the world when you sleep. Your temperature drops slightly, your breathing slows, your heart beats more quietly. You are the warmest, most complex version of what the tardigrade does so efficiently. You are resting. You are waiting gently for morning. The mathematics of a sunless solar system are full of slow and beautiful movements. With the sun's gravity gone, the 8 planets would no longer follow their familiar elliptical orbits. Instead, they would follow straight lines, or as close to straight as the gravitational influences of their neighbors allow. Jupiter, the most massive planet, would begin to dominate. Its gravity, which already plays an enormous role in shaping the solar system. Jupiter acts as a kind of cosmic vacuum cleaner, pulling comets and asteroids away from the inner solar system with its immense gravitational field, would become the primary organizing force in the now starless system. Jupiter's gravitational influence already reaches extraordinary distances. The Trojan asteroids, 2 vast clouds of asteroids that lead and trail Jupiter in its orbit, are held there by the balance between Jupiter's gravity and the position of where the Sun used to be. Without the Sun, these asteroids would drift free over millions of years, some falling toward Jupiter, some flying outward into the deep space beyond. The asteroid belt between Mars and Jupiter, already shaped by Jupiter's influence, would slowly disperse, not explosively, not dramatically, but gradually, like a crowd after an event, people drifting away in their own directions, the gathering dissolving into individual journeys. Saturn, with its magnificent rings, would continue its slow journey through a sunless space. The rings of Saturn are made mostly of ice, water ice, the same substance that would be covering Earth's surface. They are extraordinarily thin for their size, up to 280,000 kilometers wide, but in most places less than a kilometer thick. If you could compress Saturn's rings to the density of water, they would fit inside a sphere about 600 kilometers across, roughly the size of a large moon. They look permanent, those rings, inevitable, as if Saturn has always had them and always will. But they are relatively young, perhaps only 100 million years old. And they are gradually being pulled into Saturn by gravity, raining down as ice onto the planet's atmosphere at a rate of thousands of kilograms per second. In a few 100 million years, the rings would be gone. In a sunless solar system, Saturn and its rings would drift, following their straight-line path into the galaxy. The rings would still catch light, not sunlight, but the ambient light of distant stars, and they might still be faintly, softly visible, a pale halo around a dim world in a dark sky. There is something very beautiful about that image. Saturn, alone in the dark, still wearing its rings like an old habit, still turning, still magnificent, even with no star to orbit, no sunlight to catch, no audience but the stars. And if you are the kind of person who lies awake and wonders about things like Saturn's rings, you are exactly right for this channel. Leave us a like if this journey is giving you something soft to rest your mind on tonight. It means the world to know that these quiet stories are finding the right listeners. Let the image of Saturn drift past you now, slow and pale and ringed, traveling through the dark. Let it go. Let your thoughts go with it, unhurried and directionless, just floating. The relationship between darkness and creativity is one of the most interesting threads in human history. It seems counterintuitive. We associate light with ideas, with clarity, with insight. But many of the most important things humans have ever made were made in or near the dark. The cave paintings of Lascaux and Altamira, some of the oldest known art, 30,000 years old, were made deep inside cave systems where no natural light reached. The artists carried their light with them, fat-burning lamps that cast a warm orange glow on the curved limestone walls, and in that intimate, flickering light, they painted bison and horses and deer with a skill and confidence that astonishes us still. Why did they go so deep? Why not paint near the entrance, in the daylight? Researchers have proposed many explanations, but one of the most compelling is simply this. The deep cave was special. It was different from the ordinary world. The darkness itself was meaningful. Going into that darkness, carrying a small flame and making something beautiful in its light. That was an act of intention, of devotion, of saying, this place, this work, this moment matters. We still do something like this. When we want to watch a film that means something, we go into a dark room. When we want music to reach us deeply, we often close our eyes. When we want to think without distraction, we seek quiet and dim spaces. Darkness is not the enemy of experience. It is often the condition that allows experience to go deepest. By removing the visual noise of the world, darkness allows other kinds of perception to come forward. The felt, the heard, the imagined, the remembered. In a sunless world, this quality of darkness would be everywhere, always. And human art, assuming humans persisted in their underground warmth, near their geothermal springs, in their insulated caves and engineered tunnels, might become something extraordinary. Freed from the distraction of daylight, from the tyranny of the clock that the sun imposes, from the social rhythms that light and dark normally enforce, a sunless human culture might turn inward in remarkable ways. Music that exists only to be felt in the dark. Stories told not to be seen, but to be heard and carried. Art made not on walls, but on the body in the form of touch and warmth and presence. We already make art in the dark, of course. Every piece of music you have ever listened to with your eyes closed was made for that inner theater, that private stage where imagination runs free in the absence of sight. Every story that has ever worked its way under your skin did so partly because it asked you to see with your mind rather than your eyes. The best stories, the ones that stay with you, are the ones that live in the dark of your imagination long after the words have ended. This story, hopefully, is giving you something like that right now. Not a picture to look at, but a feeling to inhabit. A world to drift through without moving. A kind of rest that is also a kind of exploration. Science and sleep, it turns out, go very naturally together. Both require a willingness to let go of what you think you know, to follow the evidence wherever it leads, to be comfortable with mystery, to trust the process even when you cannot see the destination. Let the dark be comfortable. Let the not knowing be comfortable. You are in good company. The tardigrade in its cryptobiosis, the snail in its dark vent, the seed in its frozen bank, the subglacial lake going about its ancient chemistry, all of them at rest in the dark, all of them perfectly fine, all of them exactly where they need to be. There is a concept in physics called thermal equilibrium, and it is, in its quiet way, one of the most peaceful ideas in all of science. When two objects of different temperatures are in contact, heat flows from the warmer to the cooler, always, inevitably, in every circumstance, until they reach the same temperature. At that point, heat flow stops. The system is in equilibrium. No more pushing, no more pulling, no more flow. Just stillness, just balance, just the even, undisturbed sharing of warmth between two things that have found their common ground. The universe, over very long timescales, is working toward a kind of ultimate thermal equilibrium, a state called the heat death or maximum entropy, in which all the temperature differences that drive energy flow have equalized, and nothing more can happen. This is so unimaginably far in the future that it has no practical meaning for anything we care about, but the concept itself is interesting. The universe began in a highly ordered, low-entropy state, the Big Bang, and has been gradually spreading that energy outward, sharing it, distributing it since then. Stars form and burn and die and scatter their elements. Galaxies move apart. Heat flows. Everything, slowly and on the grandest scale, is working toward a kind of ultimate rest. We are, in a way, practicing that right now. The warmth of your body, which is a little higher than room temperature, is slowly and gently sharing itself with the air around you, finding its equilibrium with the world. Your breath carries warmth outward with each exhale. Your skin radiates a tiny amount of infrared light, heat, into the space around you. You are, even in rest, participating in the universe's great project of sharing warmth. You are a small node in the network of energy exchange that has been running since the Big Bang. You are connected through physics to everything. That connection is not metaphorical. It is literal and physical. The infrared radiation your body emits right now will travel outward, some of it absorbed by the walls of your room, some by the air, some eventually making its way through windows and into the open sky, traveling upward and outward, cooling as it spreads. A tiny fraction of your warmth right now is on its way to space. You are, in the smallest and most charming way, heating the universe. Lie there and be warm, and know that your warmth is real and spreading and part of something enormous. Let that be the last waking thought, or nearly the last, that you are connected, that you matter to the physics of the universe, that your warmth is not lost but shared, that the darkness around you is full of the warmth of things you cannot see. In the deep geology of a sunless Earth, something slow and remarkable would continue. Plate tectonics, the movement of the great plates of rock that make up Earth's crust, drifting apart at some boundaries, colliding at others, one sliding beneath another in a process called subduction, is driven not by the sun, but by the heat of the Earth's interior. Radioactive decay happening in the mantle and core keeps the rock hot enough to flow slowly, like an extraordinarily thick and patient liquid. This flow drives convection currents in the mantle, and those currents push and pull the plates above. The continents in a sunless world would keep moving. Slowly, a few centimeters per year, roughly the rate your fingernails grow, but continuously. Over millions of years, they would drift into new configurations. The Atlantic Ocean would keep widening. India, which is still slowly pushing northward into Asia, raising the Himalayas in slow motion as it goes, would keep pressing. The Pacific, which is shrinking, would keep shrinking. In 100 million years, the geography of our sunless Earth would be unrecognizable. The continents rearranged into shapes that have no names yet. This is one of the most quietly staggering facts about our planet. It is always moving. Right now, the ground beneath you is traveling. The rock that makes up the continent you are resting on is drifting imperceptibly, but certainly at a pace that adds up to thousands of kilometers over a human lifetime, if you could track it precisely enough. You are not on solid ground in the way we usually mean that phrase. You are on a very slow vehicle, a raft of rock on a sea of slowly flowing mantle, going somewhere, always going somewhere, even when you are perfectly still. Volcanoes, which are born where plates meet or where hot spots in the mantle breach the surface, would continue to erupt in a sunless world. They would be among the most dramatic and, in their way, life-giving features of the dark landscape. A volcanic eruption releases not just lava, but enormous amounts of gases, sulfur dioxide, carbon dioxide, water vapor. In a frozen world, the steam clouds above an eruption would immediately crystallize into ice crystals as they rose into the cold air, creating columns of ice fog that would catch the starlight and glow faintly. A volcanic eruption in a sunless world would be surrounded by its own soft halo, a shroud of ice crystals diffracting starlight into subtle colors, greens and violets and soft golds, created not by sunlight, but by the simple physics of light bending through ice. The gases released would also matter in the long term. Carbon dioxide, building up in the atmosphere from continued volcanic activity, would eventually, over millions of years, create enough of a greenhouse effect to begin warming the planet again, even without a sun. This is exactly what ended the snowball Earth periods. The Earth has its own thermostat, slow and geological but real. It produces gases that warm, and it has processes that cool. Over vast timescales, it finds its own balance. A sunless Earth would be extremely cold, but it would not be a dead world. It would be a world working slowly and patiently toward a new kind of balance. Do feel welcome to wander through the Sleepy Science playlist for more of these long, slow, geological stories. There is one about the formation of mountains, how the Himalayas are still rising, how the Appalachians were once as tall as the Alps, how every mountain you have ever seen is just a moment in a much longer conversation between rock and heat and time. These are the kind of facts that make the world feel larger and older and more patient than it usually seems. And somehow that enormity is very restful. You are very small in the best possible way. The world will take care of the large things. You just have to breathe. Let your breathing be the only thing that needs doing right now. In and out. In and out. The plates are moving. The volcanoes are exhaling. The subglacial lakes are filling drop by drop in the dark. You don't have to do anything about any of it. You can simply rest and let the world be large. There is a branch of physics called quantum mechanics, and within it, there is a property of matter that is, once you sit with it, one of the most comforting ideas in all of science. It is this: nothing is ever completely at rest. Even at absolute zero, the coldest temperature theoretically possible, negative 273 degrees Celsius, particles still move. They vibrate with what physicists call zero-point energy, a baseline of motion that cannot be removed, that the universe will not allow to be stilled. It is as if the universe has decided that absolute stillness is simply not permitted. There must always be some motion, some energy, some small and irreducible aliveness to things. This is called quantum fluctuation, and it means that even the coldest, darkest, most apparently inert corner of existence is not truly still. The vacuum of deep space, the most empty place we can conceive of, is not really empty. It is full of virtual particles that pop in and out of existence in fractions of a second, borrowing energy from the universe and giving it back so quickly that they cannot be directly detected, but leaving their fingerprints in measurable ways. The universe fizzes with energy at the finest scales. It cannot stop. It is not allowed to stop. A sunless earth, frozen and dark and silent to every sense we have, would still be fizzing at the quantum level. Every atom in every grain of ice, every molecule of frozen carbon dioxide settling on the surface, every particle of rock in the deep mantle, all of it in constant, irreducible motion. There is no such thing as true stillness in this universe. There is only rest that is relative to something else, quiet that is defined by the noisier thing next to it. Your rest right now is real and good and necessary. But even in your deepest sleep, your cells are busy, your atoms are vibrating, your neurons are processing, your heart is beating its patient rhythm. You are full of motion even in your stillness. You are a universe in miniature, never entirely quiet, never entirely still, always alive. And that is, somehow, the most comforting thing of all. That even in the deepest dark, even in the most profound quiet, even in the cold and silent and apparently motionless depths of a frozen world or a sleeping body, there is still something happening. There is still energy. There is still motion. There is still, at the most fundamental level, life, or at least the precondition of it. The fizz and hum of a universe that has never truly gone quiet, that carries its energy forward through every transformation, that finds a new form whenever the old one fades. You are part of that. Right now, in this moment, in this rest, in this breathing that you barely have to think about. You are part of the universe's insistence on continuing, on persisting, on finding the next form. Sleep is not an ending. It is a transformation, a shift in the form that your energy takes. Your awareness will pull back, and the deeper processes will carry on without it. And in the morning, or whenever it is that you next wake, you will reassemble yourself, full of something that rest gives you and that nothing else can. That reassembly is one of the most ordinary and most astonishing things that happens every single day. You close your eyes, and something complex and irreplaceable unfolds in the dark. And when you open your eyes again, you are you, still you, more fully you, carried forward. We have traveled a long way in this story, from the moment of the sun's disappearance, through those first astonishing 8 minutes of lingering light, through the first days of cooling and the emergence of starlight, through the months of falling temperatures and the survival of the deep oceans, through the extraordinary life that needs no sun at all, through the ice ages and the geothermal gardens, through the dark oceans of other moons, through the bioluminescent world that life might build for itself in the long centuries of a sunless future, through the quantum hum of a universe that refuses to be still, through the slow drift of continents and the patient memory of ice, and through all of it, what the science says very gently and very clearly is this: the universe is full of warmth. The earth is full of warmth. Life is full of warmth and cleverness and patient persistence. The sun is wonderful and extraordinary, and we are so lucky to have it. But it is not the only source. It never was. Warmth has many names and many origins, and it is more available than we usually remember. You are warm right now. You were warm before the sun came up this morning, and you will be warm after it goes down tonight. The warmth inside you, metabolic warmth, the warmth of being alive, does not depend on any external star. It is yours. It is ancient. It is the warmth of 4 billion years of life finding a way. We are nearing the end of our journey tonight, and I want to pause here and say something simple. Thank you for being here. If you have made it to this part of the story, you are exactly the kind of curious, gentle, wonderfully human person that this channel is made for. If tonight's journey left you with a comfortable thought to rest upon, a fact that pleased you, a moment where the world felt a little larger and a little warmer, then this has been everything it was meant to be. Please do leave a like or a comment, even just a word, and do explore the Sleepy Science playlist whenever your nights need something soft and true to rest against. The sun will rise tomorrow. It will be there, the same as always, sending its light in its 8-minute journey to your window, warming your morning in ways so ordinary and so profound that most of us go years without truly feeling how remarkable that is. Tomorrow, when the light comes in, let yourself feel it for just a moment. Let it land on your skin. Feel it as what it actually is. A message from a star written 8 minutes ago, crossing unimaginable distance to reach exactly you. But that is tomorrow. Tonight, the thing to feel is this: the warmth that is already here. Not from the sun, not from any star, just the warmth of being, of breathing, of a body that knows exactly how to rest when the dark comes, because it has been doing this every night of your life, and the life before yours, and the life before that, back and back to the first warm thing that curled up in the dark and let the world go quiet. Let the world go quiet now. There is nothing you need to think about, nothing you need to solve or remember or plan. The ice and the stars and the hydrothermal vents and the bioluminescent fish are all very well taken care of. The earth is turning, the oceans are breathing, the seeds are waiting in their patient banks. Life is doing what it always does, finding the warmth, resting when it can, persisting with a gentleness that has outlasted every catastrophe the universe has offered. You can do the same. Just rest now. Let your breath be easy. Let your thoughts grow soft and quiet, like the snowflakes settling on a frozen world that is, in its own way, still alive, still warm somewhere underneath, still turning, still waiting for whatever comes next. You are safe. You are warm. You are exactly where you are meant to be. Good night.